So good morning to one and all. In continuation with the previous session, time series methods, next we will discuss about regression methods under forecasting methods. The aim of the session is to familiarize the students with the concept of linear regression especially. The objectives which are mapped to the session are to understand the process of regression methods. At the end of the session, students can able to understand the models and types of forecasting methods, and they can able to summarize the process which we followed under regression method. Under linear regression, okay, the word regression means dependence, and also it involves estimating the value of a dependent variable from an independent variable. Okay, whenever the two variables are there, okay, there it involves estimating a dependent variable from an independent variable. Okay, in simple regression only one independent variable is going to be used, but in the multiple regression there are multiple independent variables will be. That is the difference between a simple and a multiple regression. In this session we are going to deal with a simple linear regression model only, where we have only one independent variable is going to be used. So here only we are going to estimate the value of dependent variables y from the independent variable x. Now the simple regression takes the following simple form, that is y equal to a plus bx, where y is dependent variable, x is independent variable, and a is called intercept and b is called slope or trend. The trend will be like this. This is simple regression represented in the following graph. Here in the x-axis we took x, that is the independent variable, and this is y, that is dependent variable. X independent, y dependent, and this is the intercept small a, and this is the slope or trend b. So this regression takes the form of y equal to a plus bx, with which definitely we can able to estimate the required values from the dependent variable y. On linear regression analysis we use various notations, and we use the notation x for the independent variable and y for the dependent variable. Then the linear regression equation will be in this form. Let us see the equation form: y equal to a plus bx, where the slope b of the regression line is given by this relation b equal to n into sigma xi yi minus sigma into xi into sigma into yi divided by n into sigma xi square minus in brackets sigma xi whole square, where the intercept a of this regression, whenever the two variables are there, one x independent and y dependent, in such cases the intercept a of the regression line is given by small a equal to sigma yi minus b into sigma xi by n. Okay, we'll use so these formulas to calculate b and a values, and finally we can able to get the required value. To explain this process, I am taking one example. A firm believes that its annual profit depends on its expenditures for the research. The information from the preceding 6 years is given below. Estimate the profit when the expenditure is 6 units. Here for the first 6 years they have given the expenditure for the research and the annual profit. Expenditure for research is denoted with x and annual profit is denoted with the y. Now for 6 months we know, now for 7th month we know the expenditure, but we don't know the annual profit. That we have to estimate now using linear regression. That we'll do now. For the 7th year, for the 6 units of expenditure, what will be the annual profit? That we can estimate now. So the calculations, whatever the first 6 years data is given, the 6 years you take, x, y values they have given already. The same I am considering the x and y values. Now the only thing is, take a table. In the table you just try to identify the product of x and y. Product, for example, you see 2 into 20, it's 40. 3 into 28, something like that. You take product of x and y for all 6 years data, and also take x square data also, and finally write the total values. Total sigma means sum of all these x. sum of y sigma y, sum of sigma xy, sigma x square. These are the values. Now you know for the slope b already one relation is there. Whatever the values you know, you just substitute there, with which the b value obtained is 2. Now find small a value. You know all these values sigma y, sigma x and all. Substitute here. N is 6. For 6 years only we are doing this. A value is 20. Now we got small a 20, small b 2. Okay. So now you know for this model, you know the expression, that is y equal to a plus bx. Now the profit you want to estimate whenever the expenditure is 6 units. You know a, you know b, you know the expenditure value also. Finally with a simple substitution you can able to get this with this relation. Okay, see y equal to a value, it's 20 plus b value 2 into x. What is x here? For the expenditure 6 units you want, so 20 plus 12 it's 32. 32 units of rupees is the y. Okay, like that we can. For example, if expenditure is some 10 units, yes, we can estimate that also. Okay, so like this, if you know the one variable from which the other one also we can able to estimate, that is possible with a linear regression. Another example I am discussing here, whenever x and y variables are there, whatever the relations we have to use, that we discussed. In the discussion, the example which we discussed in the above linear regression analysis, when the independent variable was small t, whenever the independent variable is small t, that is time period. However, the linear regression technique also can be determined with the help of the two variables. The linear regression in such cases will be in this form, and here the relation will be y equal to a plus b t. There is no x, here time t, time period t will come into the picture, y equal to a plus b t. Now here the slope b of the line is given by b equal to n into sigma t y minus sigma t into sigma y divided by small n into sigma t square minus sigma t whole square. The t is coming to the picture, and the intercept of a of the line is given by this relation. Now take one example. The historical data on the cost in hundreds of dollars for a project activity in the given is given below. Develop a trend equation using linear regression analysis and forecast the cost of activity for periods 10 and 15. You see the difference here. We know only the time period, okay, 1, 2, 3, 4 up to 9 only we know. The y value is only given here. Okay, the y value is only given here. Now we need to estimate what the cost of activity will be for the period of 10 and also 15. If you know up to 9 for 10 and 15, of course 20 divided by we can estimate. For 10 and 15 we will estimate here now with the help of a simple linear regression. The calculations, the t values and y values are already given here. Just take the product of these two, t into y, the same value is recorded here, and take t square values here and take y square values here from the known given values. At last take the total, the sum of all this, the sigma t, sigma y, sigma t into y, sigma t square, sigma y square. Now the relations you know already for slope b and intercept a. Now you know all these values, just substitute in that and see b, small b it is 2.067 and capital A it is 55.44. Now you know b and a values. Now you know the expression, that is the linear trend equation. Here it is y equal to a plus b t, bt. Now substitute y equal to a 55.44 plus 2.067 into t. Now if you want to estimate it for 10 years, the period of 10, the forecast for period 10, it is given by y equal to 55.44 plus 2.067 into 10. The answer is 76.11. If it is for 15, period of 15, the y15 will be equal to 55.44 plus 2.06 into 15. It is 86.445. You can do it for 20, 25, whatever it may be, yes, it will give. Okay. So like this we can able to get the forecast values with the linear regression analysis. Now the activities mapped to the session, this examples. Summary: in this session you have learnt about the importance of regression methods and the forecast the cost or estimation of profit using linear regression methods. We discussed examples also. And the self-assessment questions: what is the primary purpose of regression methods in production? Prediction in future what is going to happen, that is the main purpose. In regression analysis, what is the dependent variable? The response variable is a dependent one. And these are the terminal questions mapped to this session. These are the reference books and textbooks. Thank you very much.